Now we see that how it should be. See, take this problem, read it. Design a synchronous or asynchronous? Asynchronous. That is your unit 4. Okay, design an asynchronous sequential circuit that has how many inputs? That has how many inputs? Read it carefully. X2, X1. X2, X1 means you have to take in this order, not X1, X2, ma. X2, X1. In that order you have to take. So it has 2 inputs, X2, X1. And how many output, ma? It has 1 output, Z. Means you have to specify like slash Z. What are the parameters are given? See that carefully. So 2 inputs and 1 output Z. Okay. Now what condition is given? See what are the specifications, okay, of the given problem. When x1 equal to 0, output Z is 0. When x1 equal to 0, output Z is what? 0. You are very clear now. What are the things given in the question? You have to take it separately like this. Then only you can be able to draw this diagram as well as this diagram. Very, very interesting. See here. When x1 equal to 0, your output is 0. I have taken this one here. Yes. Now what is another one? What is another condition given? The first change in x2. Change in x2. First change in x2. That occurs when it occurs. When x1 is equal to 1. So that is why I taken when x1 equal to 1 and change in x2 will cause output Z to be 1. That time only your output will be 1. This is the second condition. Okay, ma? This is the second condition. Now the output Z will remain 1 until your x1. Already output Z equal to 1. But it remains 1 at what time? Till what time? Till your x1 returns to 0. Until your x1. So Z remains 1 until your x1 returns to 0. Yeah, now take some 10 to 15 minutes. Read this question neatly. All of you read this question and just to go through this condition, whatever I have written, whatever specification I have taken from the given question. Understand first. First you understand, then only I can able to proceed. Design an asynchronous sequential circuit. It has 2 inputs, x2 and x1. Okay. 1 output Z. Okay. When x1 equal to 0, what is your output, ma? Z is 0. First change in x2, that occurs while. So both you have to take it together. Okay, see, this is in a sentence. When the output will be 1. First change in x2 must be there. Also x1 should be 1. Okay, that time Z will be 1. Okay, now the output Z will remain 1. It remains 1 till x1 returns to 0. Because when x1 returns to 0, Z also will be 0. So till x1 becomes 0, the Z will be 1 based on this second condition. This is the scenario. Understood or no? Okay. Based on that, first, what is the first step? The first step is we need to draw the flow diagram. The name of this diagram is flow diagram. The name of this diagram is state diagram. From the flow diagram, you have to draw the state diagram. I hope you are very clear now. Okay. We see how to draw the flow diagram. Okay. In the previous case, I told you, these are the conditions I told clearly. Am I right, ma? These are the conditions I told. Yes or no? The given conditions I have taken. Then, how we are going to have the flow diagram? Listen carefully now here. Yeah. How we are going to have the flow diagram? See. Initially, you know that see here 2 variables are. What are they? X2. Input you have to put it first. X2 and X1 are your input parameters. And the output is Z also Z. Am I right, ma? So nothing I have given as new. They are given in the question. X2 and X1 are the input variables. And Z is your what? Output variable. They are given in the question. Okay. When you are drawing the diagram, you have to write, you have to draw like this. See, you have to put the first that one. So that's why I have put that first. Then we have to see the conditions and all now. Okay, now what you need to do? We need to see the specifications. Then we have to proceed. Okay. Now, initially I don't know what input we are passing, what output it has. So initially we don't know anything. So So because two input variables, no, two parameter you take. Initially, I hope I am just having input 0, 0. Okay, ma, I am just having what? Input 0, 0. Slash, I have to find out the output if 0, 0. See, why I have taken 0, 0? Initially, I don't know whether the x2 is having 0 or x1 is having 0. I don't know. I start the diagram from 0, 0. Means what? x2's value is 0, x1's value is 0. Like that. First value is x2, second value is x1, ma. Understood? Like that you have to take. Okay. Now see the condition. If your input is like this, what is given? x1 equal to 0 means your z will be 0. Don't ask question like, ma'am, shall I start from 1, 1 from the beginning? Yeah, you can start. No problem. You can start. But initially, before starting, we assume that all the variables will be with 0. So we are starting from 0. So you see, my x1 equal to 0. x1, say what is the condition given here? See, if the x1 equal to 0, what will be your output, ma? Yeah, it is satisfied means I no need to check any other condition. Okay. So, my x1 equal to, see here, my x1 equal to 0, it satisfies the first condition. That is why I told you, if you are looking the class, you can able to understand easily. Now, simply put, your output is 0. Your output is 0. How I put, ma? Because I had this x1 0. Okay. I had this x1 is 0. Means what they are saying, your z will be 0, they are saying. Am I right, ma? Your z will be 0. That is why this z I put here simply 0 based on the condition 1. Okay. Now what I need to do, this is the first state, no? I have to give a state name here as initially A. I have to give the state name as what? Initially A. State name you have to give in all the cases. Then what I need to do, you have to explore this. How you need to explore, no? See here. I told already, only one bit change is allowed. So I keep this 0, no, as it is. That 0 I keep as it is. Okay, ma? This 0 I am changing. That 0 I am changing to 1. This is, we are assuming like that. No problem. See, you can do like this also. This second 0 you may keep as it is. Second 0 you may keep as it is. This 0 also you can change to 1 initially. No problem at all. In any manner you can do. But at the time you have to change only one bit. What I am doing, this first 0 I am keeping as it is. Okay, ma? Next 0, this 0, no, I am changing to 1 because only one bit is change is allowed. Next time what I am doing, then what is its output, I have to see that. Slash, put slash and leave it. Next is here, first bit I kept as it is, no. So when I come here, second bit I keep as it is now. Second bit I keep as it is. First bit I change to 1 now. Okay, ma? First bit I change to 1 now. Now slash. What I did now, only since asynchronous circuit allows only one bit change at a time, 0 I kept as it is, no change. This 0 I simply am changing to 1, so now the current input is 0, 1 like that. Understood, ma? Then here what, since I kept here first as it is, here second bit I am keeping as it is. Okay, first one I have changed. So there are two possibilities only for two bits. Okay. That I have given. Now you have to apply again the condition. Check the condition. Now this is what my x2. In every step you no need to specify. This is what my your x1. Okay, every step you no need to specify. Here we specified, no. That's enough. That's enough. Now all the stage, this is x2, this is x1, like that. This is x2, this is x1. You are very clear now. Okay. Now see here what. Okay, what condition is that? First one is C. x1 equal to 0, check it. What is your x1? This is your x1, no, x1 is not equal to 0. Okay, go to the another condition. Another x1 equal to 1, yes, x1 equal to 1. Here x1 equal to 1. Yes, it is satisfying the first one. x1 equal to 1. Also, change in x2 is there, you check. Change in x2. x2 means here 0, no? x2 is 0. Already also it was 0 only. Previously also it was 0 only. It is not changed now. Same 0 only we are having. This condition also not satisfied. Understood, amma? That condition also not satisfied now. This is satisfied only. We can move to this. Because When your z equal to 1 only, we can able to move here. Okay, now z is not, z still is, what is the value? 0. So it is not equal to 1. So we cannot able to check this condition now. Okay, this is also not satisfied. I repeat, x1 equal to 1, x1 equal to 1, yes, that is okay. And change in x2 you check. But what is your x2 value? x2 means first variable. x2 means first variable is 0, but previously also it is 0. It is not changed to 1 or some, okay. Yeah. So this is also not satisfied. This is also not satisfied. Okay. That case, what you need to do now? Previous output will be considered here. Okay, ma? In that case, you have, if it is not at all satisfied, means previous output you have to put it here. So previous output is what? 0. Understood, ma? 0. Previous output is 0. We have to put it. Yeah. Now see, this is state A, no? This is what? State A. State A. Now this here we got a new state. Okay? New state. Now we have to compare this. This is 0, 1 bar 0. That is 0, 0 bar 0. Both are not same, different. So here you have to mention new state name. New state put as B. Understood? New state put as B. Okay, ma? Now you are in parallel. First you have to finish this, then you have to finish this, then you have to come here, finish this. In that order only you have to move. Okay. Now 1, 0. So here what is your x1 value? Your x1 value equal to 0. x1 value equal to 0 means, tell me. Yeah, your output also will be 0. Yeah, it is satisfied the first condition. So your output will be what, ma? 0. Simply you can put it. Am I right? So now check. 1, 0 bar 0. Compare this with this one. It is not same. That state is not same. Compare with the previous A. A is 0, 0 bar 0. But it is 1, 0 bar 0. It is new. Put a new state C. Put a new state C. Understood? Okay. Now when you are getting the new state, again you need to explore. Once you are getting the old state, you can stop doing this. Okay, new state means again you need to explore. Okay, ma? So now we see that, yeah, you do it now. You can do it now. You can check my answer with your answer. You can start doing. Yeah, this 0 I keep as it is. See here, this 0 I keep as it is. 1 I am changing to 0. I told 1 bit change is allowed. And the second bit I keep as it is. First bit I am changing to 0 to 1. Okay, what is the output? Now see here. 0, 0, yeah. My x1 equal to 0, no? x1 equal to 0, no? Satisfied or not? My x1 is here what? 0, no? Yes or no? My x1 equal to 0 means it will give the output z equal to 0. Yeah, simply put, my output also will be, my output here will be what, ma? 0. Any doubt in this? Yeah. Now 0, 0 bar 0. Is it matched with any of the output 0, 0 bar 0, any of the space? A you check 0, 0 bar 0 only, no? Yes or no, ma? A is what? 0, 0 bar 0. Put here as A. Put here as A. Very clear now? Put here as A. Okay, ma? Now here, you come here now. Yeah. Now this is what? 1, 1. What is 1, 1 means my x1 equal to 1. My see here. My x1 equal to 1. Yes, it is satisfied. Change in x2 is there. Check it. Already, yes, this is x2. But previous x2 is 0. Previous x2 is 0. Now your x2 equal to 1. Am I right, ma? Now your x2. So you changed, no? It is changed, no, now? From 0 to 1. Yes, change in x2 is also there. It is true. It is changed. Am I right? Yeah, it is changed. Me both the conditions are satisfied now. Please look into this. My x1 equal to 1 means this is satisfied. Okay. And if so, I have to check this also. Change in x2 is there. Change x2 already 0. Now it is 1. Change in x2 is there. Then my output z equal to 1. Then my output z will be 1. Understood? My output z will be 1. Yes or no? How to put z equal to 1? You are very clear now. Yes. Now 1, 1 bar 1. 1, 1 bar 1. Compare with your previous state. This is a new or not? B means no, not 1 1 bar 1. C means not 1 1 bar 1. A means not 1 1 bar 1. Am I right, ma? So 1 1 bar 1 is a new. So A, B, C we put. Next will be D. What is the next one will be D. You are very clear now. Next will be D. Like that you need to put it. Again, see this only over. This only we explored. Now in the same row C is there. In the same row C is there. Okay. So C also what you do? C also you explore. C also row by row you have to complete it neatly. C also you explore now. Yeah, now you can complete your answer. This is one. Next bit I am changing slash. Okay. Next second bit I am keeping as it is. And this is what now one I have to change it. Slash. Slash. What is the output now? Yes, ma, you are very clear. Okay. Now you find the output now. Yeah, x1 is not 0. This x1 not 0. But x1 see here, x1 equal to 1. That is satisfied. x1 equal to 1. But change in x2 is there. X2 is already 1. Now also 1. It is not changed. It is not changed. Understood, ma? Also see previous z also what? Previous z. Previous z is what? It is not 1. It is 0. It is 0. Okay. So see here, it is not it's falling into any of the categories. So previous output will come here. Previous output will come here. Very clear now? Yes, ma. So 1 1 bar 0. 1 1 bar 0 means any of that is satisfied. D is 1 1 bar 0 1 no. B, B, C, A no. 1 1 bar 0. See here 1 1 bar 1. But here 1 1 bar 0. Both are different. So different state names you should give. So now this will be E. Understood, ma? Now see here, this 0 no, this 0. Here x1 equal to 0. x1 equal to 0. x1 equal to 0 means, tell me. x1 equal to 0 means your output will be 0. Very clear now. So that time what is 0 bar 0 0 bar 0 equal to A no? Okay, ma? Yeah, it is equal to, so the state is here A. State is A. Very clear now. Yeah. Next, take this row. Take this row. What is the new state? What is the new state? D and E. But A is there. It is the old state. In the old state, you should not explore again. Okay, for the old, because A state already we explored. It will produce the same state, B and A only again and again. So you no need to explore again. Okay, ma. New D is the new. So D is the new. So for the new state you put it. New state you put it now. Yeah, now 1 I am keeping as it is. This 0 will be slash. Again here 1 0. Yeah, tell me the answer now. Tell me the answer. All are listening here. Look at me. Look at the screen now. See here. Here. Okay, ma, here for E up to this we completed, right? Okay. See here D, I have D 1, and for this 1 no, 1 is 0 now. Okay. Now this one I am keeping as it is. This 1 is changed to 0. Am I right? So both the cases are okay now. Now see this output we have to create now. Okay, that output we don't know, we have to find out. Okay. Now see in the previous, yeah, here see that what is output, what is the x1 value? x1 equal to 0. Am I right? x1 equal to 0. See, up to this already I explained. Now from here we are exploring. Okay. Now this x1 equal to 0. So you know that your z will be 0. You know that your z will be what, ma? 0. Understood? So slash 0 you are having here. Now here it see, yeah, your x1 equal to 1. See here, previous output z equal to 1. So what we told z equal to 1 means it remains 1. It remains 1 until your x1 equal to 0. Until your x1. See what is the value of x1 now? It is 0. It is not 0. It is not 0. It is 1. If it is 0 only, the value will be 0. Z will be 0. Okay. Otherwise, it will take the value 1. That's all. Because see, already z equal to 1. Already z equal to 1. Now also x1 is not 0. Okay, so if that is the third condition. Z equal to 1 means it remains 1 till x1 equal to 0. Now x1 is not equal to 0. Okay, so that is z remains 1. Again z remains 1. Okay, then so see here now. Here C 10 bar 0 is what? Your C 10 bar 0 means your C. 0 1 bar 1. Are you finding any new term? 0 bar 1 bar 1. Here 0 1 bar 1 0 1 bar 1 no. 0 1 bar 0 only is there. 0 1 bar 1 is a new. Okay, so 0 1 bar 1. See here 0 1 bar 1. That is new. So you are putting the parameter f. Understood, ma? That is why you are putting the parameter what? F. So as I told in the beginning, you have to explore again. You have to do this step and all. What I told, one you are keeping as it is. This one you are changing to 0. Okay, this 0, this second one you are keeping as it is. One you are changing to 0. This everything I told you. Okay, ma, slash, what answer now? Slash, what answer now? Okay, x1 equal to 0. X1 equal to 0 means you know it is output automatically should be 0. Okay, ma? Yeah. Now here tell me. X1 equal to 1. X1 equal to 1. And see x1 equal to 1. Change in x2. X2 is 1. It is changed to 0. So we are having output here 1. Understood, ma? It is satisfying the second condition. So what I told you? 1 means x1 equal to 1. Okay. And your x2 is changed from previous to another variable 1 to 0. So this is satisfying the second condition. So your z will be 1. You are very clear now. Now f is the new state in the next row. See 0 1 bar 1 is your f. 0 1 bar 1 is your f. Understood, amma? So you have to explore again. When you explore, see 0 I am keeping as it is. This 1 alone I change to 0. Here 1 I am keeping as it is. This 0 is changed to 1. Okay, ma, slash. See that. Already z equal to 1. But what is the third condition? When z equal to 1, it remains same till x1 equal to 0. But here x1 equal to 0, it becomes 0. X1 equal to 0. So your output is 0. Understood, ma? So your x1 equal to 0 means your output automatically will be 0. That is why. Okay, ma? That is why you are having here output 0. From 1 it becomes to 0 because of this x1. X1 equal to 0. Until x1 equal to 0 only it will be 1. Right? Now here what is the answer? X1 equal to 1. X1 equal to 1. Am I right, ma? X1 equal to 1. But see, previously also z is 1. Previously z is 1. But it remains same. Until your x1 equal to 0. Okay. Now your x1 is not equal to 0. Until it is 0, it remains. So that z equal to 1. Also see here. X1 equal to 1. Change in x2. That also will be satisfied automatically. Change in x2. So your z equal to 1. It also satisfied automatically. A and D are old states. A and D are old states. So no new states found. No need to explore again. We can stop it here.